Welcome to The Explainer. Today, we're doing a total masterclass on engineering the context window. We're moving way beyond basic instructions to look at how we can truly shape and control AI behavior.
So what do you actually put in the context window? You already know it's the model's working memory, it's everything it sees at once. But this is the central question for today, because here is the undeniable truth. Whatever you feed the model literally determines what you get back out of it.
Okay, here's our roadmap. First, we'll uncover the secret of prompting. Second, we'll look at the 3 API roles. Third, and this is our main focus today, we're diving into the sheer power of few-shot prompting. Fourth, using positive constraints. And finally, chain of thought reasoning. Let's get right into it.
Number 1, the secret of prompting.
Most people just assume prompting is all about being super specific. You give clear instructions, add some context, and boom, you're done, right? Well, actually, there's something much weirder happening under the hood. Prompting isn't just writing instructions, it's shaping which patterns in the model get activated. We really need to flip our mindset here. You aren't just typing commands into some empty void. You are actively triggering specific clusters of vocabulary and reasoning styles that the model picked up during its massive training phase.
Think of it like talking to a toddler. If you say, "Don't throw the ball," all they hear is "throw the ball." Look at these two instructions. On the left, we have "don't use bullet points." On the right, "write in paragraphs only." To us humans, they mean the exact same thing. But when the model processes the left side, it hits the words bullet points and immediately activates its internal bullet point pattern. It then has to try and suppress that pattern, but suppression doesn't always win. You told it not to, but you literally planted the idea right in its working memory.
Section 2, the 3 API roles.
Once you wrap your head around pattern activation, things get really wild when you jump into the API. Because in the API, messages aren't just plain text, they are structured arrays, and every single message has a distinct role attached to it. The biggest one, arguably, is the system role. This is the instruction set by the developer that lays down the behavior, rules, and personality of the model, invisibly shaping every single reply. So assigning a system role, like Senior Python Developer, isn't just a fun little tone change. It activates a highly specific cluster of patterns, vocabulary, and developer logic from the training data. Behind the scenes, this messages array relies on 3 interacting roles. The system role, like we just discussed, is the developer talking, setting the rules completely invisibly to the end user. Then there's the user role, which is the person actually using the app and asking the question. And finally, the assistant role, which is the AI model's generated response.
To really make this click, compare standard ChatGPT with the API. In ChatGPT, OpenAI writes that system message for you. They just hide it in the background to make your life easier. But with the API, you write the system message yourself. You build the entire messages array from scratch. Taking control of that system role is a massive part of what makes the API so much more powerful than a basic chat interface. You get to dictate the rules of the game.
All right, Section 3, the power of few-shot.
We are now entering the absolute core of this explainer. If you want the ultimate tool for controlling your output format and seriously locking in accuracy, few-shot prompting is exactly what you need to master. Few-shot prompting means including an example directly in the prompt to show the model exactly what kind of input to expect and what format to reply in. Remember, every single word you add to a prompt acts as a constraint. So giving the model a literal perfect example of success is hands down the most effective way to constrain its behavior and drastically improve its output.
Structurally, inside the API, the difference is huge. A zero-shot prompt is just 2 messages, your system constraint and a real user question. But for few-shot, we are actually inserting a fake user message and a fake assistant response right before the real question. We completely invent those intermediate messages just to establish a rock-solid pattern for the model to follow. Let's see what happens when we skip this step. If we use a zero-shot prompt to ask the model to classify a restaurant review sentiment, it totally guesses at the format and spits out this overly enthusiastic rambling. It says, "The sentiment of this review is negative. The customer experienced a long wait time, which suggests frustration and dissatisfaction with the service. You asked for a simple classification, and it wrote you a whole essay. It had no idea you only wanted 1 word, so just assumed you wanted a full breakdown." Now contrast that with this. Positive. That's it. By using a few-shot prompt where we literally fed it an example of a simple 1-word classification beforehand, the model outputs exactly the single word we wanted for our next query. No guessing involved whatsoever. So, why does few-shot prompting so fundamentally improve your output?
It's because one single example accomplishes three massive goals at once. It shows the model exactly what kind of input to expect, it shows the precise format to reply in, and it completely eliminates the model's need to guess. It's just incredibly efficient token usage.
Section 4. Use positive constraints.
We're moving into some advanced territory now, building on how models handle all these constraints we're putting in place. A lot of developers fall into a classic trap here. They use negative constraints, like don't be verbose or avoid jargon. Instead, you want to replace those with positive targets. Tell it to be concise, one sentence per point, or use simple words a high school student would understand. These positive instructions are measurably, consistently way more reliable than the negative ones. Going back to our toddler analogy, you never want to accidentally activate a bad pattern just to tell the model not to use it. Give it a positive target for sure.
Section 5. Chain of thought reasoning.
This is our final technique for today, and it's all about shaping the model's underlying logic rather than just fixing its formatting. Chain of thought prompting is when you guide the model to reason through a problem step by step rather than letting it jump to an answer all at once. If you toss it a generic command like plan my trip, the model tries to guess everything in one single shot, and that's when it usually starts hallucinating. But forcing sequential steps conditions the model to systematically build toward a much better, highly accurate final answer.
So instead of that generic command, you break it down. Step 1, check my calendar for the travel dates. Step 2, search for flights within my budget. Step 3, find hotels near my meeting location. Step 4, summarize the best options. What's so cool about this is that when the model writes out the answer for Step 1, that generated text instantly becomes part of the context window. It then uses that new context to reason through Step 2. Every single step sets up the foundation for the next one.
Let's wrap this up and tie all this theory back to reality. Everything we've covered today, the system roles, the few-shot examples, the chain of thought instructions, it all consumes tokens. It literally all has to fit inside the model's working memory. These message structures completely dictate how the model samples its answers, and it is absolutely vital to remember that the system, user, and assistant turns all live together in that exact same context window.
Which leaves us with a pretty massive question to ponder. As we fill up that working memory with these arrays, how does the precise order of information in a long prompt change what the model actually pays attention to? When you think about production agents out there assembling 19-section, programmatically built system prompts, the order of those constraints becomes everything. It's definitely something provocative to chew on as you start building your own custom logic. Keep experimenting, keep constraining, and I'll catch you in the next explainer.